Example, inclusion exclusion probability from table number 1. The table below, all values in thousands, shows data for 89,000 single parents on active duty in a certain year. What is the probability that a person selected at random is A, in the Army or Navy, B, a female and in the Army? So as we look at this table, it is organized in this way. We have a column for Army, a column for Navy, a column for Marine Corps, a column for Air Force, and then a total column. And we have rows labeled male for each of those categories, female for each of those categories, and the total for each of those categories. So I'm going to point out the pertinent information here. So for part A, in the Army or Navy. Well, being in the Army or the Navy consists of the number of parents in the Army plus the number of parents in the Navy minus the number of parents that are in the Army and the Navy. Well, that requires us to look at the total row at the very bottom for Army and Navy. According to this table, there are a total of 32 parents in the Army and a total of 33 that are in the Navy. Out of the 89,000, now these are all in thousands, so there are 32,000 in the Army, 33,000 in the Navy, at a total of 89,000 overall. So in this problem, these are actually mutually exclusive in that there are no parents in the Army and the Navy. So we can actually just add 32 plus 33,000. 32,000 plus 33,000. And each of those for probabilities are out of 89,000. So 32,000 divided by 89,000, which I'm just going to calculate as 32 divided by 89. Plus 33 divided by 89 as a fraction that is 65 divided by 89. And again, since those were not mutually exclusive and we had an OR, we could then use the inclusion-exclusion principle. Part B, a female and in the Army. Now this actually doesn't require the inclusion-exclusion principle at all because it says and, a female and in the Army. Well, if we look at our chart, there are 9 female in this table that are in the Army. So for this, it is 9 out of 89. It's a matter of reading that. 9 out of 89 for a female and in the Army. Now, if instead this said a female or in the Army, we would take the total for female, which is 23. I'm just going to add that actually. We'll make this part C. Female or in the Army. So female would be 23 total, if we look at our total column, out of 89, plus Army, which would be 32 out of 89, minus female and Army, which is the 9 out of 89. And so if we add and then subtract 23 plus 32 minus 9, that is 46. 46 out of 89 is, well, that doesn't reduce, so 46 out of 89. For female or Army. Example, inclusion-exclusion principle probability from table number 2. Same setup as the last question, except we now have a new part, which is in the Marine Corps and a male. But again, this doesn't require the inclusion-exclusion principle because it says and. Inclusion-exclusion only applies to or statements. So for this, we can count the number of Marine Corps and male. Well, on this table, we show in the Marine Corps column 6 male, 1 female for a total of 7. So this means this is 6 out of 89. Remember, these are both in thousands. 6,000 out of 89,000, which is 6 over 89. And that does not reduce. So 6 out of 89 is the probability that we have a Marine Corps, someone in the Marine Corps who is also a male.